Hello everyone. In the last video, we built a particle emitter style project. That means hundreds of particles spawning from a center, fading out, and it loops forever. But this one is different. I click wherever I click on the canvas, the same thing appear. Number of numerous particles explode outward, and every one of them has its own direction, a speed, a gravity, like pulling it down and friction and slowing it to stop at certain point. The difference between the previous video and this one that we are building today is a particle system. That is, the last time the particle just moved, but this time we control where this particle should explode. Within the time period, it explodes continuously. Along with this, there is a mouse movement. When we click, it also explodes. Both things happen at the same time. So that is what we are going to do, and that is the difference between previous one and today's thing we are building. So yeah, welcome to Scratch Start. Today we are going to build a particle physics based system. This is the initial output without JavaScript, initial browser output without the JavaScript. So let's start directly with the coding now. And I have created variables using identifiers, and also I created the repeater part, the canvas resize function. This is just a responsive function. It don't have much like importance. It is just for the responsiveness. And then I have also created the global variables. Like in the previous video, I have created the particles array, animation ID, and whether the animation is passed or it is happening. And I have created a set of colors array where we write the function below. That function will draw color from this array. So let's start with the important main part. So first thing we have to do is create the function or the logic to create the colored balls. So in the previous video we did only one thing, because the balls or the sparks originate from a single point, the particles originate from a single point, and it just scatters from a single source and vanishes. So it is a loop and it happens again and again. So we have created object there, but here we are not going to create an object, because here two functions are happening, and it happens one part happens continuously and another part happens only when we click the container. So there are two things happening. So we can't just create an object again and again repeatedly. So that is what we require. But so we are going to do, what we are going to do here is create a class here. This is a new thing we are doing. Create a class named particle. This will handle all the things the object does, what we did in the previous video. But it will handle this thing for all the things, all the particles, all the origin points, and all the other places. So I am creating a class called particle, and inside that I am creating a new constructor with the conditions or the parameters x and y. These are the things we are going to use. X and y are the main values we are going to use. So in the constructor I am using this keyword, this in the x coordinate. X coordinate is just x coordinate, and then the same constructor y coordinate is just y coordinate, and then this constructor or the particle will have a radius. For the radius I am using math random method, math random multiplied with 5 and added with 2, and then it will have an angle too. So I am creating a variable called angle, and this angle is calculated by using just pi, using the pi value, math random and math pi. Math random multiplied with math by, and it is multiplied with 2. So now we will get the angle here, and then we need another value called speed of the particle. It is calculated with math random value multiplied with 8 and added with 2, and then we will go straight to this keyboard, and then the particle will have directional velocity. We did that in the previous video too, directional velocity, but there we calculated using math random math floor method, but here we are not going to do that. Here we are going to use a new thing, the cos and the sine value, the trigonometric values. So math in the x direction, the velocity in x direction, we are going to use the cos value, because in x direction it is the opposite side. So cos angle, we will take the angle value from the calculator thing, multiplied with the speed. This is nothing but just a normal thing. It's just a normal formula, mathematical formula, and this doesn't need a much explanation. It is just another trigonometric function, that's all. The same with the math velocity in y direction too. Math in sine direction, sine degree. For theta I am using angle here, degree multiplied with the speed, that's all. And then this will also grab the gravity here. Gravity value is, I am giving the fixed value of 0.15, and then it will have the friction. For the friction I am giving fixed value of 0.985, and then it will also have the alpha value 1. This alpha value means it will appear clearly at the beginning, and the particle will also have a lifespan. So for the life I am giving it 100, and then for the color of the particle I am using colors array for this. From the colors array, using math floor method and math random method, I am calculate this. Math floor of math random multiplied with the length of the array, colors array, length of the colors array. So now the particle will be created using all this using this particular constructor. Now we will create the particle using this constructor. Now to create the particle I am writing a function called create particle. In create particle, inside the create particle I am pushing all these created particles inside the particles array. Particles dot push new particle, push the new particle with parameters x and y inside the particles array, that's all. Now we will take care of the explosion part. You see, you should have seen the introduction. The particles explode inside the container. So for that control I am writing a function called create explosion with parameters x and y coordinates. Inside that I am creating a variable called amount equal to 80, that is the intensity of the explosion, and I am using for loop to make it repeat again and again. Let initial value I am taking I equal to 0, and the condition is I is less than the amount, and we should increment it by 1. If those conditions are met, we can create the create the particle with parameters x and y. So this loop will repeat again and again until these conditions are met. And now the mouse input, that is this also you should have seen in the intro. When I click the inside the container, there arises the explosion too again there. So I'm selecting the canvas here, and inside the canvas I'm just clicking the screen. So I'm using click event. I'm writing a function with exact that clicking event as a parameter. Inside that I'm creating a variable called ret. I'm using ret. I'm creating a variable using get bounding client ret. This will calculate the size inside. Then creating another variable mouse x. This is calculated using the events client text minus the size of the rectangle in the left, and then the mouse y. It is created using event client y and ret top. Now we can create the explosion. Using the mouse x and mouse y values, that is the parameters. These are just the parameters where our mouse is placed. That is why I didn't explain much about this mouse x and mouse y. And then random demo, that means you should have seen the screen. Within the explosion happens inside the screen between a fixed period of time. So I am creating that thing now. So for that I am using set interval method. I am creating a function here. Function if I am using if logic. If it is paused, we should return. We can do nothing about it, so the function will be stopped here. Or else the second part is we have to create the x variable, that is the x coordinate, using the math random method. This is a random explosion, that is why I am using the math random method. Multiply with the canvas's width. And y is calculated by using the same math random method, but we are using the height. Math random canvas's height. Now we can create the explosions using the x and y coordinates we calculated. And now we have used the set interval method, so I am giving interval at 3 seconds, 3 second interval. So 3000 millisecond or microsecond. And now we will write the next part, that is we should update the particles. If within the canvas, the particles will move during the each movement, that is each frame, the particle should be updated. So within 1 second, in the first millisecond, the particle will be in x1 y1 position. In the next microsecond, the particle will be in x2 y2 position. So the particle's coordinates, its velocity, its direction, its gravity, gravitational pull and friction, everything will be affected. So for that I am writing a function called update particles. Inside that we should update the particles continuously. So I am using for loop. I am writing a function let I equal to particles arrays length -1. The condition is if I is greater than or equal to 0, and it should decrement by stage, because the particle is going to disappear finally, so it is going to decrement. So using for loop we are writing the whole operation, the whole sequence of events that is going to happen. So I am creating a variable called p. This p is taken from the index of the current particle, that is particles arrays index, current index. So now for the gravity section, the ball will have the gravity, that is the particle will have gravity. So p dot, it is gravity will pull the ball in the y direction, downwards. So velocity y is updated version of p dot gravity, it is added with the gravitational value. And then we have the particles friction. For the friction I am using the x directions velocity and y directions velocity. Velocity will act in the either way it will act. So we are going to calculate all the directions. X, it is multiplied with the friction. Friction v dot velocity y is multiplied with the velocity in y direction. Sorry, friction in y direction. Friction in y direction. Now for the movement, when these things happens, it should also move. So we have to change the x and y coordinates. X coordinate, it will change accordance with the velocity in x direction. So I am going to add the value velocity in x direction, that is p velocity x. For the y coordinate, the same thing but in y direction. P dot velocity y. Next, the ball should shrink as it goes down. As you can seen in the intro, this happens. So for the shrinking purpose, it should change the radius. So p radius is, it is multiplied with the 0.985. Now it should fade away at one point. So for fading, we should change the transparency. So p dot alpha, it is subtracted with the 0.012. Then it should also have a life. It is also connected with the alpha's value too, so it should decrement by 1. P life should also change. So next we need to remove the dead particles. To remove the dead particle, we are writing the condition. The alpha should be 0. That means the transparency is 0, so it should not be visible. The radius should be very low and the life should be also 0. So that means the particles are dead. So the condition is if p dot alpha, if p dot alpha is less than or equal to 0 and the radius, if the radius is less than 0.3 and the final value is life, if the life is less than or equal to 0, the life is less than or equal to 0, that we have to splice the particle from the array. That means we have to remove it. particle dot splice using the index and from the next value, from the index and next value. So that's all. So now the particles will get updated continuously. Now we have to start the drawing inside the canvas. So for that I'm writing a function called draw particles. Inside draw particles I'm selecting the particles array, and for each of the particles I should write the function. Function with parameter as a particle, and inside that we have to save the previous values. So ctx save, operation is started with ctx save, and next after that we have to establish the alpha value to ctx global alpha is calculated using the particles alpha, and then it is a circle, the particle is a circle, so ctx begin path. Since it is a circle, I am missing arc method. I am missing the x value from particles x value, y value from particles y value, y coordinate value, particles radius, and the starting angle 0 and the ending angle as the math y. Since it is a circle, I am missing the circumference, math by multiplied with 2 pi r. So that's all. Now we have to give color to this arc, like to the circle, so to the particle. So ctx fill style is equal to get the particles color, and then it have the shadow ctx shadow color equal to the same color we used, and then we will have the shadow blur too. Shadow blur is 18. Then we have to fill the ctx fill and restore it, ctx restore. So that's all the functions, all the operations are now finished. Now we have to update this UI. So for this it is a simple function. Use the function update UI. Inside that we have to change the count, just to say just a text content change. So select the particles count variable and change its text content to length of the particles array. Particles array's length. Now we have to clear the canvas after the animation is finished. So for that, writing a function called clear canvas. Inside the clear canvas we should make all the values as null. So for that I am using initially the fill style value as RGBA values 2, 6, 23 and 0.18, and next using ctx fill rect value I am removing all the particles here. 0 0 the canvas's length and width. Canvas's width for the horizontal and canvas's height for the vertical. So canvas's width and height. Now we have to start the animation. This is nothing, just to include all the functions we wrote above, include everything. So it should happen in that sequence. So the sequence is important here. So I'm writing a function called animate. Inside the animate, I'm using if logic. If it is passed, that is we should, if it is passed, we should return it. We can't do anything about it. So we should return it, and then we should start the function operation with the clear canvas, because the previous particle should be cleared. Clear canvas, and then we have to update the particles, and then we have to draw the particles, and then we have to update the UI. So the particles will form. So after that we have to change the animation ID using request animation frame. Request animation frame, use the animate function here. So that's all. Now for the button operations, it is just simple. For select the clear button, add event listener, event is click. Inside the write the function. We should clear everything here. We should change the particles array's length to 0. Particles array's length to 0, and then we have to clear the CTX. That's all. Clear CTX. That's all. CTX, clear the rectangle. Give the value 0 0. Canvas's height and the canvas's width. Canvas's width and the canvas's height. Width and canvas's height. And then we can update the UI here. Update UI. And then next is the pass button. So the pass button, the same operation but different. We have to pass it. The event is happening. So select the pass button variable. During the click event, we should write the function. If it is already passed, we can't do anything. Already passed, we can return the operation, and then we can change is passed is true. Is passed is true, and then we can cancel animation frame using the animation ID. So now this operation is also finished. Now we have to start the play button. Here it is exact opposite of the pause button. Select the play button. The event is click. Write the function. If it is not paused, we can return. That is, if is paused is false, we should return. We can change is paused is false, and then we can include the animate function and continue the animation. And then now we have to start the initial frame to start the loop again, loop freshly. So use clear canvas function to clear everything on the screen in the canvas. Then use the update way function to update it, and then animate to start the animation. So now everything is written, all the logics and the object creation of the particle, everything is written. So let's go to the browser and I started it. So now see there is some kind of error. Wait a second. It is nothing, just a syntax error. I have fixed it. See, the animations happen for every 3 seconds. When I click the frame, the explosion is happening. One explosion happened. See, 1, 2, 3. Third second, another explosion is happening. So between each intervals an explosion happens. Along with it, additionally, when we click in the canvas, an explosion happens. So this is how this works. It has many uses. I have simply done it to just to experiment and learn more about this animation, go deep into this particular thing. I will also go into other types of animations and other basics too, but today we will stop here and we will go through more in the next sessions. So yeah, please don't forget to like, share and subscribe, and leave comment about what you think about this video and what I should do next. And yeah, that is it for today, and I will meet you guys in the next session. Thank you.